My name is Megan Sullivan, and I'm here today to present to you low-intensity selective logging does not negatively impact forest structure or diversity in an African tropical forest. Tropical forests globally are increasingly under threat due to profit-generating land uses. Selective logging is a compromise between forest use and protection. It generates income, but it does not completely clear forests from the land. Across the forest landscape, canopy cover largely remains intact after selective logging occurs. However, selective logging can result in changes that impact forest structure and diversity. How strong these impacts are and how long they last are unclear, but much of the variation seems to be due to logging intensity. We conducted our study on how low-intensity selective logging changes forest structure and diversity, and came up with these hypotheses. We expected that a temporary increase in the heterogeneity of understory light levels would occur after selective logging, and that negligible effects on basal area would also occur after selective logging due to the sparse nature of low intensity logging. We also expected increases in understory tree diversity and density due to increases in forest heterogeneity. And we expected to find increases in understory liana levels due to environmental changes in selectively logged forests that benefit lianas. We conducted our study in Gabon, which is a country in Central Africa, and we set up vegetation plots across different ages of logged forests in one logging concession in Gabon. We set up 80 plots in total and set up our plots across 4 different blocks representing 3 different treatments. Our 1 year since logging treatment is represented by the green triangles on the map. The 10 years since logging is shown by the red circles on the map, and we have 2 control treatments represented by the blue crosses on the map. Our vegetation plots look like this, and we measured seedlings, saplings, and adults in the plots and subplots across all of our different treatment areas. In total, we measured 10,125 trees and 1,394 lianas. We found that recently logged forests have slightly more open canopies, so higher mean canopy openness, and more variation in canopy openness, so higher standard deviation of canopy openness in the 1 year since log forests than in 10 years or control forests. We also found that saplings had higher rarefied richness in the 10 years since logged plots, and that saplings had higher species evenness in the 10 years since logged plots than in control plots. Similarly, we found that seedlings had higher evenness in the 10 years since logged plots as well. Sapling size lianas made up a higher proportion of the community in older log forests. So we found that the relative liana abundances in the 10 years since logged plots were higher than in 1 year since logged plots or in control or unlocked plots. In conclusion, we found that recently logged forests had a more heterogeneous light environment. We found that logging had negligible effects on basal area, so no real differences. We saw that there were modest positive effects on sapling diversity. Otherwise, selective logging didn't much affect seedling diversity and did not at all affect adult diversity. And the only evidence of negative effects that we found were an increase in lianas after logging in the older log forests, indicating that this may be the most effective area where management can improve by using liana removal techniques to deter lianas from growing after logging. I would like to thank all of the organizations and people that offered me support throughout this project, and thank you all for listening to this talk. If you'd like to contact me, my contact information is below. Thank you.